Hello and namaste. This is Traveler's Diary. My name is Asis. Today I'm going to talk about the applications of machine learning in renewable energy. Talking specifically, I'll be talking about the time series analysis for solar power production. In this presentation, I'll be talking about different data pre-processing techniques. I'll be talking about different deep learning, machine learning, and classical statistical forecasting method. And I will also try to compare the model accuracy based on the prediction error. So let's get started. So basically the presentation will be in three different parts. On the first part, I'll be talking about the basic application of machine learning in renewable industry. And I'll be also talking about the different data pre-processing techniques. And this part will be covered in this video. On the next part, I'll be comparing the one classical statistical forecasting method and one deep learning forecasting method, and that will be the content for the next video. And on the last part, I'll be comparing 9 different machine learning and deep learning models. So this will basically be the different part that I'm going to talk about throughout this video series. And just to guide you through, the model that I'm going to study is ARIMA model, that is a statistical model, and univariate LSTM model. So these two models will be discussed in part 2. I'll try to compare the performance of these two models, and the different model that I'm going to test and try for my analysis will be the multivariate LSTM, CNN, GRU, stack GRU, bidirectional LSTM, stack LSTM, encoder decoder LSTM. So I'll be talking everything in a detail. This is just to guide you through what I'm going to talk about in the next couple of videos that I'll be presenting. And these two models are one input variable and one output variable. Basically these are univariate model, and this will be compared on the part 2 of this video series. And these are classical statistical forecasting method and deep learning method, and rest all different models uses a 6 input variable to predict the one output variable. And so what are the different input variable that I'm considering is power output, GHI, DHI, temperature, wind speed, DNI. I'm going to talk everything in a detail. This is just to give you an overview of everything. So let's dive into the first part of this presentation, that will be the basic application of machine learning and data pre-processing. So let's dive into the topic. Let's start with the definition itself. What is machine learning? Basically, for human, we learn from past experience. If we touch anything for the first time and if it's hot, we're not going to touch the same thing again because we learn that it's hot. But machines are not capable of doing that. For that to happen, we provide a lot of data where machines are capable of understanding the trend, understanding the features of the data, and try to predict and behave like a human. So in a nutshell, machine learning is we enable machines to think and behave like a human. If we see the bigger picture, artificial intelligence covers machine learning and deep learning model. So artificial intelligence basically means we enable machines to think like a human, and machine learning is a supporting system, supporting framework for that to happen. And deep learning comes under machine learning. Basically, a deep learning and neural network are the multi-layer machine learning model. Whenever we have very complex data and large number of data, we use deep learning and neural network. We call it neural network because the way that model receives the data, processes the data, quite resembles with the human nervous system. So this is what the basic definition of machine learning model is. So to get the more insight of it, let's talk about the types of machine learning algorithm. In the first type, we have supervised learning, where for example, if we provide a lot of images of apple, we also label those images as apple. So machine will be able to understand whenever there is a new image of apple, it is going to predict it as an apple. And we have something called unsupervised learning, where humans do not intervene in the decision making process. When we provide a bunch of data, the model itself will understand and it will itself learn the features in the data, and it will distinguish it will classify the data based on the features it learned. So it is unsupervised learning. It is called unsupervised because humans are not intervening on the decision making process. And we have something called reinforcement learning, where it learns from the feedback. Suppose if we are watching videos on YouTube, and if we see a lot of cat videos, we're gonna have a lot of cat videos recommendation on the YouTube. And basically, if we switch it to if we start looking the videos of cars, you'll be getting a lot of cars videos. So it basically comes from the feedback of the user. So model will try to see what feedback or what the users is trying to see, and it will provide based on that. So it's a reinforcement learning. And the topic that I'm presenting, that we are trying to discuss, comes under supervised learning, that is time series forecasting of solar power production. And we call it time series because we looked into the last eight term and we predict the ninth term. So basically, we already know what the ninth term is in our training data, and we try to test on the new data. So it's basically a supervised learning. Uh, so so that's what different types of machine learning algorithm are. So let's talk about the role of machine learning in renewable energy. The first role will be in forecasting. It might be forecasting of power production, demand, or maybe weather condition. So talking about renewable energy, so the biggest problem with the renewable energy is the unpredictable nature of the energy sources like solar and wind. And this is one of the reasons why renewable energy is not coming up as a mainstream energy source. Although we have very limited fossil fuel, the renewable energy is a suitable option to compensate the limited fossil fuel we have. So the biggest problem is with the unpredictable nature of the energy source. So the role of machine learning could alleviate the unpredictable nature of the renewable energy, and it will try to make it more reliable. And how it's going to do it? It's going to do it with the forecasting. So if we are able to predict the what would be the solar irradiation tomorrow at 5 o'clock, what will be the wind speed tomorrow at 5 o'clock evening, we can make and we can prepare beforehand if there is any power fluctuations tomorrow. So it will basically helps to make the renewable energy more reliable. So it's very one of the very important features, very important role of machine learning in renewable energy. And our presentation will be on this forecasting of solar power production. So let's talk about the other applications of machine learning. The second application could be a grid management. So if we talk about the grid management, it's about the cyber security. Like renewable energy are always always in a remote places, and it's always should be in a network because you are trying to monitor it from the large in a long distance. So if there is something in a network, it's always vulnerable to cyber attack, and it is one of the biggest problem that is with the renewable energy nowadays. If I remember of the cyber attack, it was on the Ukraine attack of 2015, where the Russian group attacked the Ukrainian power system, and there was a power outage for 6 hours. And that was basically done as a kind of a terrorist attack. And another was a colonial pipeline attack. It was in the US in 2021, and it was for the ransom money. So the hacker demanded somewhere around 5 million to remove that virus from the system. So the company had to pay it. So this kind of attack are very frequent nowadays. So how the machine learning model will be helping to get rid of this kind of problem? So machine learning model can help to make the system, the network, more secure when there is any unethical, unauthorized intrusion in the network. foreign intrusion in the network, the machine learning will be able to understand it. It's not a good intrusion. So basically it will stop it right there, and there is a less chances the system will be less vulnerable to the cyber attack. And it's very critical because somewhere people sitting in some part of the world could, you know, attack the system here in the United States. So it's very crucial to have that. And machine learning model, machine learning algorithms are helping to get rid of this problem. So grid management, cybersecurity is a very important area where machine learning model is helping renewable industry to make it more secure and more reliable. And the third applications or role of machine learning in renewable energy could be the maintenance. And in the renewable energy industry, there's a large wind farms or maybe the solar farms where like the maintenance is one of the biggest challenges we have. So like if there is any, like in the figure you can see, if there is any icing, if there is any erosion in the wind turbine, it is going to decrease the power production by a significant figure. As per the research, if there is icing, the power production could be reduced by somewhere around 80%. And it's not very visible from the ground if there is any icing or not. And also if there is erosion, the power reduction could be more than 5%. So these kind of problems are there with the renewable industry, mainly the wind turbines. So the machine learning models could help to solve this problem or identify this problem or make the maintenance faster. So if we have a drone that can capture these images, where the machine learning model is implemented, where it can identify if there is any icing in it or maybe any erosion in it, so it will help us to get notified if there is any problem with the um, turbine. And similarly, in a large solar farm, if any solar plate or panel is damaged by the hailstone, we cannot know specifically where the damage is. So basically, if the drone can go and capture the image and try to classify and try to see if there is any damage, so the particular solar panel could be replaced. So the maintenance becomes a lot more easier with the application of machine learning model. So it is also one of the important application of it. So after the introduction to the application of machine learning in renewable energy, so let's start how we implement the machine learning and where is the starting point. And the starting point is the data. So we collect the data. So if we are trying to do a time series analysis for solar power production, or maybe the time series analysis for the wind speed prediction, so for that we need data. And how we are going to collect the data? It might be from different meteorological tower, or maybe from the sonic anemometers in case of wind, or maybe the lidars for the wind speed measurement, or maybe different instrument to measure the solar irradiance. So basically it starts with the data. So we measure the data what we need, and the second steps it comes is data cleaning, and it is one of the important step in machine learning algorithm. So the data we get from those instruments that I just talked about are very messy, something like this guy is stuck in a wire. So the data cleaning is very important step in machine learning model. And normally the data scientists spend 70% of their time cleaning the data because the real world data are messy. And the data cleaning is one of the very significant step in machine learning model. And but what makes the data messy, that confuses the machine learning model, is that the first thing is missing data, because when we are recording the data, there might be some power tripping out and you are not able to measure the data. So there's a lot of missing data, and maybe the outliers and noise because the instrument might not accurately measures the data every time, and there might be very less training data, or there might be very excessive training data. So there are some situations where we are not able to record data for the long time, or maybe we have a lot of data, so that's also one of the problem. And there may be many irrelevant data, or there might be some human error. So the data cleaning is very important step here. The machine learning models are not capable of understanding if there is any missing data, or maybe there is a lot of outliers, maybe there's a lot of irrelevant data. So this needs to be clear before implementing a machine learning model. And basically the machine learning model starts with the data collections, data preparations, and data training, evaluations, and we predict based on that. So this is basically a simple flowchart how the data cleaning. So in the data cleaning process, the first thing is it's a data imputation. So if there is any missing data, we try to impute it, and it is not very random. There has to be some relation to it. So let's talk about it. So imputation is basically a technique used for replacing the missing data with some substitute value to retain most of the data or information of the data set. So there should be a very good substitution in the case of missing data. And if we talk about the basic example of data imputations, the first is mean median imputation. So if we see the column on the left, we have two missing value, and the table on the right, the missing value are imputed by either mean or the median. So this is pretty easy, this is pretty simple. However, this is not very recommended way of imputing the data, because this method will not preserve the correlation between different value of the variable. So basically the machine learning model, the time series analysis basically works on that principle. It will try to see the the relation between the different values at different time step. So this method is not very suitable. It's very basic method of data imputing. So let's talk about the other different data imputing technique in the next slide. So we have another data imputation technique, regression imputation. This is one of the widely used data imputation technique. In regression imputation, if we see on the column Y, we have three missing value. So in this kind of data imputation technique, what we do is we look the most correlated variable with Y. So we have X, Y, Z, and W. We'll try to see the what column is most correlated with Y, and we will create an indicators such that if I is equals to 1 for no missing value and I is equals to 0 for missing value, then what we do is we fit a baseline between column Y and the one that is most correlated with Y, and we try to fit a linear regression model on that column, and we try to replace the value where the I is equals to 0, where there is a missing value, and we replace the value. So basically we perform a linear regression for data imputations. So basically in regression imputation we have two different kind of imputation. One is deterministic regression imputation, meaning that we exactly substitute the value that comes from the regression model, and we have stochastic regression imputations where we substitute the value that is missing with the deterministic value, but we also add some random variable that comes with it. So basically the stochastic regression imputations works better than deterministic regression imputation, because they also consist of some random value associated with the prediction, but the stochastic predictions will also have some limitations. Basically, if the data is heteroscedastic, meaning that the data, where its variance increases along as we move, in front of, like as we move in the x-axis, if the variance is increasing, the stochastic regression imputations are not able to capture the not able to do the data imputations better. So it is some limitation. However, this is one of the most used imputation technique if there is any missing data in the data set. So after we talk about two data imputation technique for missing data, so let's see how our data looks like. So our data looks like something like this. We have output, we have DNI, DHI, GHI, temperature, and wind speed, and the data is pretty clean because we took it from the NREL database, so the data is pretty clean. But what if the data is not clean? So for that example, I remove some section, some values in some time period for a DNI value, and I will explain what I will do if there is any missing data. So if there is any missing data, what I will do is I will try to see the correlation. So this is the heat map correlations between different input variables. Then what I will do is I will try to see the DNI, what is most correlated with, and I will perform the regression imputation. Specifically, I'll be talking about that. I'll be doing the stochastic regression imputations, and I'll try to impute the value in here, try to fill that gap with the regression imputation. So that is one of the important step that you need to do if there is any missing data. But our data of analysis, we have pretty clean data because we got it from the database that is already clean. But when we talk about the real world data, it's not clean. So if we see these two pictures, are taken from the real world data, where in the first pictures we have some missing data towards the end, and in the wind speed data we have some outliers or noise where the speed is less than 0, and for the wind it is not possible to have that. So basically, when we are taking a data from the real world instrument, there is always um, data that is not clean, that need to be clean. There is some missing value, or there is a outlier. So this kind of problem is associated with the machine learning model, and it is one of the very important steps that need to be followed before implementing any machine learning model. So let's talk more about some more data imputing techniques. So these are the hot deck imputation and cold deck imputation. Basically, we replace the column if there is any missing data with the other column where the data is more similar. We call it hot deck and cold deck imputations, and there is also KNN imputation. It's a machine learning data imputing technique where KNN stands for K nearest neighbor. So basically, if there is any, so if in the pictures, if we need to predict or classify the value, this green value, what will do it will try to see the nearest parameter, nearest variables where the data is, and it will try to measure the Euclidean distance, and it will try to classify this green dot if it belongs to red or if it belongs to blue. So in this way it will classify, and it will help to impute the data as a best substitute for that missing data. So data imputing is very important technique in very important process in data cleaning. So in data cleaning, after data imputations, outlier handling is another important step. Basically means the piece of data that is in abnormal distance from the other point. So in order to handle the outlier, the first step is we need to detect if there is any outlier in the data or not. And for this, we visualize it. We can visualize it either by the regression graph or by the box plot. So the first thing is we visualize it, and after we detect there is outliers, we can either remove that data, or we can either impute that data with other base substitute. If we see these pictures of the wind speed, we can see that the wind speed is less than 0 in some portion in the history. So that is not possible. That is certainly a noise or the outliers. So this data can either be reduced, that get removed, or maybe imputed it with the regression technique, or maybe substitute all this 0 minus value to by 0. So that could be one substitute. So after data imputations, what we do is we handle the outliers. So in data cleaning, after data imputations and outlier handling, what we can do is there's something called one-hot encoding, where we convert the data into binary form. It's not that machine learning is not able to understand the other data, but if it is converted into binary form, the machine learning model is able to efficiently predict, and it requires less computational memory. So one-hot encoding also comes into the data cleaning, where we convert the data into binary form. And the other thing is data normalization. We normalize the data, so that each variable will have equal impact on the result. And we also do the data scaling if there is, or data augmentations. If there is a very less data, so what we do is we try to augment the data so that the model does not suffers from the underfitting. And we also do data grouping if the grouping of data makes the prediction easier, and more reasonable, or it makes more sense. We group the data. So these are other basic data cleaning process that is involved in machine learning model. So finally, after we get the clean data, after data imputation, outlier handling, one-hot encoding, or maybe after data normalization, data scaling, after all that, after we clean the data, what we do, we import the data and we implement it in the model. So let's understand the first model, ARIMA, but it is going to be on the next part of the video. So till then, bye bye. Please subscribe my channel Traveler's Diary. See you next time. Bye bye.